Welcome everyone to this discussion panel. This is going to be the first of a series of events called Runbook that is brought to you by DareData Engineering. DareData Engineering, we are recognized as the fastest growing AI company in Portugal. We have a network of around 50 members, and we're working with the companies such as TechEver, Noj, and Einken. Now, we are here to discuss about geospatial data and its role with data science. There are petabytes of geospatial data out there, and they're available for everyone to use, and they have an enormous potential for improving all of our data science workflows. This event wants to showcase this potential, and we're trying to answer questions such as what are some of the examples of geospatial applications that we can have. There's also the question of how can we integrate the geospatial data with data science and the fast-paced AI world that we're currently living in. We also want to know the technologies that we can use when we are working with geospatial data. And to help us answer these questions, we have with us Professor André Barriguinha. So he's a professor here at Nova IMS. He's been a critical person for GIS here in Portugal, has been very relevant for the Urban Analytics Lab and for the Magic Information Management Research Center. There's also Miguel Almeida. He's a senior data scientist, a map enthusiast, has a dual PhD from Técnico and Alto University, has done a fantastic study on the lack of metro and railroad access in the Lisbon metropolitan area. Currently, he's working for Porto Digital. He's continuing now to pursue his passion with GIS and data science. And last but not least, we have Professor Bruno Jardim. He's also a professor here at Nova IMS. Aims to modernize the information systems in the public organizations, and he is currently creating smart indicators for better urban living. So, now, going to the first topic, we are all very curious to know what kind of projects you have been involved in. So, the first question I have is, could you share with us a project that you are particularly excited about? Now, you've sent me some slides. Well, there was DareData, and you've sent me some slides. I think we can start by Professor André.
So, thank you, Gustavo. You are too kind with your introduction. Just a disclaimer. So, I represent here more of the GIS part. So, I'm not a data science. I'm a junior data science, I hope. And one of the projects when DareData challenged me to be here today, I remember one of the projects that we created in our laboratory, here in Urban Analytics, Nova Cidade Urban Analytics Lab. And it's not about cities, so it's about wine. So I think it's a good a good start. So basically, I think this showcases what is the potential of GeoAI and geospatial data science as for now. Okay, so basically, what we created here was a digital knowledge platform for the Douro region, the Douro demarcated region. I don't know if you ever tasted Porto wine. So it's a region in the north of Portugal, and it has 250,000 hectares of vineyards, and it is a heavily regulated region. And there is a public institution, that is EVDP, that regulates all the activity of the value chain inside that region. And it regulates from the production, from the actual grapes, until it reaches the glass. So every aspect of the production is regulated. And once we did that, so this is a very comprehensive project. We work with data scientists, we work with Power BI, we work with business intelligence, and of course GIS. And one of the challenges that they addressed to us was, okay, we have now a model that can predict the actual yield in the entire region, and it's based on pollen concentrations. But the problem is that the model only predicts for the entire region. So I only have a minimum and a maximum number of kilograms of grapes, and I want to know more. I want a multi-scale approach, and I want to know for each one of the sub-regions, for each one of the parishes, what will be the yield for that year, and I want to know it in advance. So I can plan more easily all the work that EVDP does every year, and I can also transfer that knowledge to all of the actors inside the EVDP and the region. Okay, so we started looking at their data set. We did a comprehensive literature review, and we come up with a model, a new model, that was based, of course, in AI. And we put together, and Bruno also worked in that project, and we put together a model that goes and get remote sensing data, in this case, vegetation index, which is called NDVI. We went and get climate data from actual automatic weather stations, and the production historical data that EVDP has from, in this case, we use from 2016 until today, and we put it in an LSTM framework, okay? And then we created and developed this model. You can see there, this is an overview of the entire platform. You can see that we characterize the region from pretty much the grape till the glass, and you can see a lot of dashboards, a lot of information, and in the bottom corner, you will see all the information regarding the remote sensing, regarding the NDVA. We also did some work regarding the bioclimatic indexes and heterogeneous regions that we come up. And the final one is the actual model that we developed that can predict at an early stage what will be the yield in each one of the parishes. The model worked very well. The best error that we have is 8% error. It's better than the actual model that they have, and it's more linear in what is the prediction. So it doesn't have very variations between the years, and it was very nice to work with EVDP. Because of course they have a lot of data, and that is also an important question here. But nevertheless, it's also applied research. So we developed a model that they actually use, and they made informed decisions based on that actual model. I don't know if I want to say more, but I think it's just an overview of a project where GeoAI was used, and it actually matters for an actual institution for, of course, the decisions that they make every year.
I think that's a great example. Maybe we can move on to another example now from Professor Bruno, and then we can maybe have some questions at the end. Yeah, exactly.
Okay, so it's always hard or unfair to talk about our projects after Andrea talks about this, because it's wine and everyone loves wine. But I also think that everyone probably loves to have a good built environment to be in. So I'll try to give you an example of a project that we did also in the Urban Analytics Lab, which is a lab that me and Andre work in, but regarding another topic. So this was a project that we also used the machine learning and geographic information systems, and I'll explain you in each part and what tools exactly we used. But this tool that we created, which we call the walkability score, was developed inside this project called CTEC. CTEC was a project that we developed together with MIT, with Instituto Superior Técnico, and NOS, the communications company. And the idea for the project in general was to develop tools, innovative tools, because after all, we are a university, so part of what we do is research and innovation, and innovative tools in order to be able to fight climate change, and in this case, carbon emissions specifically. That's why it's called CTEC, C for climate and technology for climate. And we had a use case, an area where we developed our use case, which was 3 parishes, Parque das Nações, Marvila, and Beato. And so we had this area to employ these different innovation tools that we wanted to explore. And one of the things that we suggested, it was not the only one, we had other solutions, including energy efficiency in buildings and a few other things, but one of the solutions, and this was the one that I was responsible for, was the walkability score. So by the end of this, of developing this solution, there was a paper that was published. You can follow the QR code there. It's actually also part of my PhD dissertation. So when Gustavo said that I was developing indicators for sustainable development or for smart cities, this is one of those examples. In any case, so the first part, I guess it was the geographical part where we retrieved the street map for the street layer for the entirety of the 3 parishes, and specifically we were concerned about the street level analysis. And this can be done in many ways. So most walkability indicators, there's a huge literature on the topic. Most of these indicators are generally focused on the neighborhood level or at the census tract level. And so they are not so granular as the point where you can actually analyze specific streets that allow you to make specific data-driven policies. So if you know that a street has a problem, you can actually try to go there and solve it. And if you know if the problem is about the sidewalk width or about the slope because it's causing some issues there, you can go there and solve it. If you calculate walkability at the level of the neighborhood, it's too general. You cannot apply specific measures. So our idea was to do it at the level of the street, which was already innovative, but we did we went even further. We actually calculated it at the level of the point. So we actually mapped, although it doesn't show there, we mapped walkability at each meter of the street. So for each meter of these 3 parishes, we had a walkability score. And how did we calculate the walkability score, and what does it mean? So for the ones that are not so familiar with the term walkability, it pretty much defines how friendly the built environment is for pedestrians to walk there. So pretty much how good would you feel to walk there? And that can be, can have different interpretations. It could be more utilitarian because you can just use it because it's close to your job place or it's close to some place that you want to go. So there's the accessibility side, but there's also the experience of being able to enjoy walking there because of the view or because you're close to the sea. And there's the aesthetics as well, which could be part of what I said just now. And so there's a lot of levels. Some are more objective, others are more subjective, and that's the first part. How can we acquire data for these different components in order to be able to objectively calculate walkabilities without depending on asking people, because surveys are also always very expensive. They do not they are hard to escalate because you can ask for some people like 100 or so, but then in the next year did something change after some construction, so we tried to automatize this process more or less. And what we applied here was, in terms of tools, we used OpenStreetMap to extract the amenities that existed in the area. This is open source. They don't cover all the amenities. And by amenities, what I mean is hospitals, any service like transportation, stadiums, gardens, touristic points, all of this, which can be classified in different categories. And we used OpenStreetMap for that. And then we applied the calculation at 2 levels. One, using GeoPandas, was to calculate the distance score, which allowed us to, at each point, know the accessibility score to a given amenity. Let's say the accessibility score to health. We should cover hospitals, pharmacies, and a few other things. And we also, for that point, we also had an accessibility score for sports. We should cover like gyms, stadiums, and a few other things. And also the accessibility score for green places. And so we had, you can imagine a table where each row is a point of the street, or a street, but in this case a point of the street, and each column is one accessibility score. So we had multiple sub-accessibility scores. Out of those accessibility scores, we summed them and summed it to sidewalk width. Okay, these were all normalized values, of course, and subtracted slope. And this was based on what we found in the literature in terms of the impact, positive or negative, of the variables. And we ended up with a walkability score for each point of the street. So the table that I was just saying, you can add now another column, which should be the sum, or that formula, sorry, applied to each row, and you get the walkability score for each point of the street. So what does this mean? Before I show you what this means in visual terms, to make sure that our model made sense, remember in this project we were working with NOSH, and NOSH has a lot of data regarding mobile phone communications, and so we were able to know where people were. So we decided to follow the utilitarian view of walkability, and we said, okay, places that are more walkable are places that on average have more people there. That's what the decision that we took in terms of the underlying theory, let's say. And so we defined actually two models, two regressions pretty much, and this is a part of data science, which was one model for weekends and workdays, and we calculated how well our values predicted the fact that our variables predicted people being there. And in a lot of places, specifically in the center, where closer to transportation services, like the Estação do Oriente, but also close to some places with green areas and so on, we ended up having a very good score. In other places, not so much. This is a geographical weighted regression. It's not a normal regression because it allows to account for the geographical variation and the spatial variation of the data. And then we applied, we used Power BI to calculate or to present the visualization, because the calculation was already done in Python. If you follow that QR code, there's the website for the project, and there's the actual dashboard, and you can look at it directly. But we were able to map Parque das Nações in terms of its walkability, and of course this will always be a little bit relative to what you prefer. So this, for each person, there's different weights to be attributed to different places, but or to different variables. But we ended up mapping the entire area. And one of the interesting things that we are able to do with this is to create a street profile. And I think this is the one thing that distinguishes this work from the others, is that by mapping this, we are able to understand how a street varies in terms of its walkability, pretty much. And we can define zones for intervention and understand what interventions are required based on the accessibility scores, on the sidewalk width, or in other variables that might be considered. Besides that, and this was part of what we did in that dashboard as well, and it's something that we are exploring more, which is we can create a simulator that allows us to either change, for example, I will increase the sidewalk width in 10%. How will this impact my walkability score? And we can, by this, we create a tool that enriches the tools or the techniques that are available for urban planners in order to understand how they should design streets. And so when I said in the description that you guys used to present me, that I was creating, or we are creating, indicators for data-driven cities or regions, that's the idea. It's that we design urban space with the use of data and understanding what are the patterns of our public spaces. And the decisions that are made are always driven by data, so that you can justify what you're doing, why you're doing something. Is not just gut feeling. And in the end, I think we have a good tool here. We actually are developing something similar also for the North region in one project that we have from the PRR money, and we are going to develop something similar for a walkability score for touristic attractions. And yeah, I look forward to maybe share it with you in the future once we have that work done.
Thank you, Bruno. Well, it's indeed very interesting when we are able to look at a map and identify the places. And well, next time you go through Parque das Nações, for example, you already can bring a little bit of knowledge with you. So yeah, now for the last person for this topic. So it's Miguel, please.
Can you guys hear me? Yeah, cool. Okay, so I'll actually take one of the last sentences Professor Bruno mentioned when he said that we should try to base our decisions on data. So I work for Porto Digital. Porto Digital is, I mean, summarizing it and sweeping a lot of things under the rug, but it's kind of like a digital transition hub and an innovation hub of the city of Porto. It's a non-profit. It's owned by those three institutions at the bottom, which might be difficult to see. The Porto Municipality, which is the majority shareholder, the University of Porto, and Metro do Porto. So it's a non-profit, 100% owned by public capital. I'm specific. Porto Digital does way more things than just data science. I'm going to sweep over that. I'm part of the data team, and we are, if I had to summarize our mission, it has to do with this last sentence that Professor Bruno mentioned. We're trying to support the municipality to make more and more their decisions based on data. Of course, even without data science and data visualization, they were not making decisions blindly. But with good visualization tools and good statistical analysis tools, we can help them do better. I'm actually going to bring here maybe 2.5 projects, not just one. Sorry, Gustavo. But this is maybe the most interesting one and the one I've taken more time to work at Porto Digital. So this is a city overview dashboard or a screenshot of it. It's an interactive dashboard, but here just a screenshot. Right now focused on mobility. So the circles that you see there, mostly green, but some of other colors, are traffic detectors, just some coils that are under the pavement of roads that can detect metallic objects going over them, like cars or buses or trucks. And they measure traffic intensity, so vehicles per hour, every 10 minutes. We can infer not the speed, but at least the speed variation. So we can infer if traffic is moving faster or slower. And with that, we can inform the mobility division of the city of Porto, how is the traffic doing in real time, almost real time, with something like 20 minutes delay. One of the things, so this is not new for the mobility division. They could already see this in a proprietary tool. What is new here is that because we're developing this based on open tools, and we'll get to that later, we can integrate this with whatever we want if we have the data, because we're building it, right? It's not proprietary. We did not hire a company to build this for us. You also see there some markers, yellow and gray. Those are unexpected occurrences, things like traffic accident or maybe a pipe that burst and the street needs to be closed for repairs. There's some, let me see if I can find the laser pointer. You won't see it anyway. So there's some yellow and red lines on the map. Those are expected constraints. So when a constraint is unexpected, the mobility division just logs a latitude and longitude, so there's a marker for that. But when they have an expected constraint, you see something like this. Okay, they actually draw a polygon on what is being affected. Red here means a street was closed. I'm not sure if these have to do with the new metro lines being built in Porto, but there's a lot of construction work happening in Porto over the new metro lines, just like here in Lisbon. The yellow areas are constrained in some way, but they're not closed. Maybe they're closed at night, or maybe one lane has been closed, but another lane is still open. And so this is already something new. It's not new data. They know this because they are actually logging the data into the database that we grab to build this tool, but they now have a more overview of how the traffic is doing as well as the constraints. And that's something new. So that's more the data science, let's say, prior to machine learning, more like understanding your data and visualizing your data. That's more what we're doing here. Professor Bruno also mentioned OpenStreetMap. One of the cool things we do is So these traffic detectors, these coils under the pavement, in many locations, Porto has built them one per lane. So we can actually see the traffic per lane, not just like in Google Maps where you can see this street is congested, but we can see, well, this lane is congested and this one is not. And we also connect to OpenStreetMap to be able to draw the lines of the lanes. Here they're mostly straight lines, but if a street is curved, you can maybe see it there on the right here that some of the lines are slightly curved. We can also consult OpenStreetMap or the schematics of the city themselves to know what each lane is for. For example, on the right side over there, you see that the northernmost lane, so the lane at the top, you can use it to turn right or to go through, meaning go straight ahead. The middle lane, you can go straight ahead. The southern lane, so the one at the bottom of the street, you can use it to turn left. The colors here mean kind of similar to what you see on Google Maps. So more red and orange means slower traffic. Yellow means somewhere in the middle. Green means faster traffic. And in the future, we can use this for a lot of things, such as routing of emergency vehicles, trying to correlate this data to buses and bus delays. We actually have real-time position of buses in the city. Although there's a layer to show that on this dashboard that I didn't capture, but we're still not doing a lot with that data, to be honest. But we have access to it. So we're still at early stages of building like this overall view of mobility in the city. So this is one project. To get to 1.5 projects, I promised 2.5, we'll get there. This is a similar dashboard, but instead of looking at real-time data, we're trying to study the impact of football games, specifically in this case, games at the home stadium of Futebol Clube do Porto, one of the 3 largest clubs in the country and definitely the largest in the Porto city. The stadium is at the right side of the municipality near that cluster of red circles that you see there. That's where the stadium is located. And what you're looking at is the speed of traffic about half an hour after the game finishes, the speed of traffic versus a baseline. The baseline is just same time of day, same weekday, but without a game. So comparing days where we have a game and there's days where we don't have a game. There's a bit of statistical voodoo here that I did to be able to compare multiple games that do not always happen at the same time and do not always happen on the same weekday. But big picture is just comparing same time of day, same weekday to days without a game. As expected, you see a lot of red near the stadium, and if any of you has gone to a football stadium and left, you will see that traffic is a mess, especially when you leave, because everybody's leaving at the same time, whereas people do not arrive at the same time, especially on weekends, and these are weekend games mostly. You see some red scattered throughout the map. This is very early stage work. I built this last week, actually. I suspect some of them might be outliers. I still have to figure out what they are. But it's still kind of encouraging that you see a lot of red near the stadium. That maps well to what is our gut feeling of what happens after a game. The streets near the game are a mess. Why are we doing this? Because later in the year, a project it's a project that is already ongoing, collaboration between Porto and Munich, which is analyzing the stadium of Bayern Munich, Allianz Arena. We will start implementing measures to try, we meaning the municipality, will start implementing measures to see what, let's say they decide to close off a street or to police illegal parking more or what have you, whatever measure you can think of. We want to know, is it working? Are we making this map better? Do we see fewer reds here or not? If we do something that annoys the population and it doesn't improve traffic, then maybe we should think of something else. So this is the preparation for that, where we know what's happening. Finally, this now for a personal project. This has nothing to do with Porto Digital. This is the project that Gustavo mentioned of just mapping distance to rail stations. So the height, you might be able to see that this is a 3D map, hopefully. The height is the population data taken from the census to 2021. So this kind of tells you where more people live or fewer people live. And then the shades of green represent distance to metro or train or the trams of Metro Sul do Tejo on the other side of the river. The beige color that dominates the map means that walking to one such station is at least 20 minutes. This is not straight line distance, is walking distance. So there's some computational effort here to be able to compute all pairs of walking directions between, I think it was something like 35,000 polygons of the census and 150 something rail stations. And then the multiple shades of green are areas that are closer and closer to rail stations. The darker greens are closer. So you can see roughly to that dark green region is basically the municipality of Lisbon, which is quite well served between train and metro. And then you see at least two big regions, one more to the north, which is Odivelas. It's been a bit on the news about a year ago that it was going to lose the yellow line and all that, if you were paying attention to the news, which is a big cluster of people that are very far from rail, as well as some people more to the west of the city, which is the region of Alfragide, Miraflores, this kind of region. Also a number of people there that are underserved by metro or train or tram. So when I built this, I was hoping that this would help inform people and even decision makers of where should we build these things, because they are expensive infrastructures. You shouldn't build them on every corner. And that was my goal when I built this. This is accessible publicly if you search in Lisboa para Pessoas, which is a local newspaper. This ended up as an extended article there. The interactive maps are there, or just talk to me later and I'll point you to it. And yeah, I think I'm done. Here you go.
Well, thank you. So that's around 4.5 projects then. So the idea here, exactly. So now I would like to bring in some audience engagement. So we would open now already for some questions. Let's grab like maybe one or two. I've seen there's one over there, so we can go straight at it.
Thank you. Now I feel bad. I don't actually have a question, more of a suggestion.
Yes.
I really like this map with the green. Maybe you could change the colors to show the areas that have a lot of population and are far from the train, like red, right? Because then you would focus your attention to where do you need to put the infrastructure.
It's actually in the article that I mentioned. I did that for two regions, the two regions I mentioned. I thought it would be a bit of information overload to show all of that here, considering that I probably already went over time a bit in my original intervention. But it's there. I can afterwards, if you ask me, I can point you to the article.
There was another question back there. Yeah.
I don't know if this is a better one for after as well, but I was curious about the magic voodoo that you use to figure out days of the week and time of day.
Sure. So essentially, traffic is not the same at every time of the at different hours of the day. So a game that starts, for example, at 8:30 in the evening will necessarily have different traffic properties around the stadium compared to a game that starts, for example, at 6 p.m. without this being due to the game. Just because traffic at 8:30 p.m. is different from traffic at 6 p.m. So how do we deal with this while at the same time being able to use the fact, for example, the map that I was showing compares 33 games, all home league games of 2022 and 23. And I want to make use of that. So the voodoo is that first I compute per game the ratio of the speed between what happened, for example, let's say a game starts at 6 p.m. and I want to know what happens 2 hours after the game starts, which is roughly when people start to leave. So I would look at data for 8 p.m. and let's say the game is on a Sunday. So I will compare that game specifically, the traffic of the game day, with the average traffic on Sundays at 8 p.m. for that game. That gives me a ratio for that game. And then I compute these ratios for all the games. And then I do a median, maximum, minimum. So percentiles basically for the 33 games. So basically I have per hour after the game, so 2 hours after the game, I have 33 ratios, and I can compute these percentiles on those 33 numbers. That's the voodoo.
Thank you. So any, like maybe we can take a last question for this topic. Anyone interested? Yeah, there's another one.
Okay, I kind of have a question more for the walkability score, I guess. It's, well, I guess the question pertains to like, how well do you think that, I mean, okay, this captures a lot of data, that's, okay, how walkable it is, but yeah, there's always the notion of, okay, is it a dangerous road? Is it, so you have like the airplane going through a lot of streets on Lisbon. Like, do you think it's actually representable of like the real picture of like, oh, I don't want to walk on that street? Or is it more of a, okay, this is a good area to live in and you have good amenities around it?
Thanks for the question. And it's a very good question. There's always, as I said before, we try to make it objective indicator, which means that we need to have data, we need to rely on data, so it must not be subjective. And the way we would do that in your example, this is something that we are trying to implement further on the work that we are developing, is information about noise level, because that's important. You're mentioning the airplanes passing by. Also information about air quality, which is also important. It is something that while we're walking, we don't really know that maybe it's poor air quality or good air quality, but it's something that should be considered. And also data from Waze, which gives us information about the traffic jams and so on, which is a proxy for like how people feel secure in terms of proximity to cars or something similar to that, and also to other things like congestions and so on. And so we are always trying to improve, but always based on this idea of data-driven approaches, and so this requires that we have access to that data. But it's something that we are always considering and trying to apply to the models that we create. And hopefully, for the example in the north that we're going to create, we are going to be able to apply those data points. In different cities, there are going to be, of course, different data available and also different challenges to tackle. One of the things that we also try to do is to make this as scalable as possible, and that's always challenging because in some cities you have data quality or air quality sensors. In other cities you don't. The reason why, for example, we used OpenStreetMap instead of using the data about the restaurants and all these services from Lisbon itself, it was because we wanted to make something scalable that was not dependent on that city particularly, and we could extrapolate this for other areas as well.
Oh. Yeah, I think that might be okay.
Be recorded, I think.
But is it okay? Yeah? Then okay, go ahead.
Hi. May I ask about the same project? Isn't the price of the flat a kind of objective point about the street? For example, as might be seen in part of nations, the walking street on the seashore isn't considered good as a red flat part. But the flat prices there are like one of the highest in the Lisbon. And don't you find this correlation really useful in terms of writing the multiple score? Because mostly in the nice walking streets with the flat.
Yeah, so again, great question. So the price of the real estate there, first of all, it's a very hard data point to get, although we do have access from Confidencial Imobiliário, which is a company that it's pretty much a database for real estate. But it could be a way of measuring how good was the indicator, but it's not completely true that the places with the highest price are the best ones to walk. For example, one of the areas that's more expensive in Lisbon, it's Restelo, which is actually one of the areas that is less served. You were showing in your graph before. It's less served in terms of services of transportation. And transportation, it's something that being close to transportation might be a good accessibility to have in terms of walkability because it can take you somewhere else. And so it's not always true. Generally, I think the most isolated areas where you can have big houses, mansions, and so on will be more expensive. They don't have a great walkability. People generally own cars and move with cars. But yeah, I think it still could be a great, and that's actually something that I also thought of before, which was to analyze the correlation between walkability and the real estate prices. But I think, and this is something I also discussed a couple of times with the CEO of this company that provided us the data, which is he thinks that accessibilities will not have any impact for the price of real estate. And he thinks it has more to do with either proximity to center or just the culture of the neighborhood, okay, and the area that allows you to build bigger houses.
Let's now move on to the next topic. So now we're going to explore the intersection between geospatial data and data science. So the question I have for you is, how do you see data science and AI? And this is going to include machine learning and the trending topic now of large language models. How do you see them playing a role in the future of geospatial data? I guess this time we can start with Professor Bruno.
Okay, thank you. So I think I can give the example maybe of the project that Andre presented, the one with IVDP, in the sense that I also participated in that project. And so, as Andre said, he has a role that resembles more GIS specialist. So he knows a lot about geography and he knows a lot about analysis that you can apply with geography. And well, my role in that project was more of a data scientist. And so this is where things intercept. So one of the things, and as Andres said, that we did was to predict the yield production of wine, and what I brought to the table was the ability to apply, for example, the LSTM. So I had some experience. I did my master thesis in the area of NLP. I worked in a startup in this area as well, and so I had experience working with text. And one thing that I found, and it was very curious, is that text is very similar to time series. Okay, text are just time series, but words instead of values. And so, and you can read it backwards. It's useful to read it backwards, while time series generally not. And I brought this the ability to deal with data, to apply machine learning models. While Andre, in this case, more linked to geographic information systems, build the ability to retrieve, for example, images or sensor data, and to know, like, have the business knowledge. It's not business, but the knowledge about the specific topic. In my particular part, that was applying the model to guide me through what the results actually meant. What they were really about, and if the model make any sense or not. Because of course I'm looking at it, and as a data scientist, you might know the technical part, but you cannot know about every subject. I'm probably oversimplifying the GIS part, and I think Andrea then can cover for me. They explain it a little bit more in detail because there's a lot of work to be done there as well. I also think that it's something that is common in everything that we do, actually in every subject. You're going to start to need like a data team or someone that knows about data, because most of the things that we are doing, they are going to deal with data. And so if it's geography, if it's accounting already deals with it, in the banking sector as well, finance, anything that you want to deal with is going to require data. For example, in my case, I argue that urbanism or urban development and politics and so on will also require data. And so that's where data science enters. Then there's particular points where that data is geographical. And there you're also going to need someone that is specialized in geographical data, because the data science sometimes might be good applying things technically, but might not have the particular knowledge of a given and specific subject.
Yeah, definitely. There's even many statistical methods and stuff that's just very specific to geospatial. Now let's hear Miguel. You want to tell us a bit? Oh, yeah, please.
So I think when I was, we knew these questions a bit beforehand. So this morning I was thinking a bit about how to answer this question. And one of the things that popped into my mind was when I started my career, data science wasn't really a term, or at least I didn't hear it that much at the time. This was 2012, long time ago. And I implemented a lot of algorithms by hand. So if I needed a random forest, there was no scikit-learn, or maybe there was scikit-learn, was very unknown at the time, and I certainly didn't know it. And a lot of algorithms were missing from it. It was still buggy. I remember watching a talk at Instituto Superior Técnico at the Lisbon Machine Learning School of a German guy whose name I don't remember. One of the creators of scikit-learn saying, hey, we're building this and we think it's going to be something, we hope it might be big one day. And then fast forward not many years, and nowadays, would you ever implement a random forest? I did. In 2012, I implemented a random forest. Nowadays, I wouldn't do it. So that I think is going to be one of the trends for sure, that some of these statistical analysis that Bruno was mentioning, some of the things I was using, for example, for this, right? This in the literature, by the way, this is called planned special events, PSE. So if you want to go to Google Scholar and look up papers of people who study the impact of football games and other events, look for planned special events. Right now, if you want to do a statistical analysis of the impact of a planned special event, whether it is football games, concerts, things like Queima das Fitas or São João in Porto, which are big events, you have to do the statistical analysis, what I call statistical voodoo. You have to do it yourself. Right? And I might do it, and then Professor Bruno or Professor André might use something different, and that makes it harder to compare. I think in the future, you will have this in GeoPandas, or you will have a GeoScikit-learn, or a GeoTensorFlow, or what have you, which will both standardize as well as make it easier for someone that is just starting on the topic, or even just someone from DareData who wants to deliver something to a client in a week and not in 2 months. And hopefully by using the same tool that thousands of people use, there's fewer bugs, there's more confidence in the tool, all of that. So I think definitely there's going to be a trend towards that, just like scikit-learn and pandas, and now TensorFlow and all that, and PyTorch, and now ChatGPT one day soon. Another trend that I think will appear is, so right now, at least speaking from Porto, the case that I know best, I have some contacts within data science people in Lisbon as well, working for ML, for example. Another trend, I will corroborate what Professor Bruno said. ML is hiring data people. I don't know if right now they are, but the last year they've hired 1 or 2. TML, the guys that are behind Carris Metropolitana, so the buses, there are not the buses in the Lisbon municipality, but the longer range buses on the whole Lisbon metropolitan area, they are hiring data people. Lisboa Enova, which is an innovation agency of the municipality, they are hiring data people, so that's definitely a trend. And then another trend that I can imagine is cities now are, at least the cities that I hear about from these collaborations between Porto and other cities, this is a very common trend. Cities trying to centralize their data lakes, to start to have one source of truth where they can look at the data, and the data is kind of standardized throughout longer periods of time. And I think it's a matter of time until cities start using this to predict something. For example, there's a master's student at Porto Digital that is developing a prediction system for this data, the traffic data, or maybe better for this data. So the real-time data. Can I predict the traffic tomorrow? Can I predict the traffic in 1 hour, right? This very simple problem. Now, right now she's just using the time series itself, and she's not using any information that may be predicting the top lane on the right side road on this diagram might have something to do with predicting the middle lane. Right now it's completely independent. But for sure, knowing that there's a football game tomorrow should impact this prediction. And so as cities centralize more and more of their data, I think prediction systems which already exist in many cities around the world will be able to access more, should I call it, integrated data from multiple sources within the city, from multiple divisions. Things like predicting air quality should be tied to, is there a major event? Is there good transportation for that major event? Is there a strike of public workers which will paralyze trains and the metro? So these are the steps we're taking right now. Right now meaning this week, next week, and so on in Porto. And I think this is fairly common from the cities that we've been in touch with. So right now, I think we don't yet have these fancy machine learning, or not many, but in the next 3-5 years, I think we're going to start seeing some very cool stuff. In terms of LLMs, since you mentioned that, we are using LLMs, but not for geospatial data, just for text, just for text data right now.
Doing some data cleaning.
Yeah,
right? Yeah.
Using it for more automated data, or at least for suggestions for data cleaning.
Yeah. Yeah, I think it's very interesting what you mentioned. I think it really comes down to the geospatial part, which is the quote that I was introduced to when I was taught about geospatial, which is that one, everything is related with everything, but near things are more related, right? So yeah, I guess like geospatial data, when working with data science, really brings that specialness, right? So for finalizing, Professor André?
No, what Gustavo already said, it's the first law of geography. Okay, so it's from Tobler, and what's interesting is that the geographic world, as we see it, is very complex, and I think that is one of the main reasons that we can rely on AI and machine learning and all of these tools that we have now at our disposal to help us construct what is a better model of the reality and to solve actually real problems and based on data, as Bruno already said. The actual concept is not new, so I look it up, and the first time that it's not GeoAI yet, but it's automatic geography, automatic cartography, is almost 40 years old. And there is a book from 1997 that actually uses the term GeoAI. So it's per se nothing new, but of course there are a lot of stuff that are new. We have the exponential growth of data, of course. We have a lot of more computational power that we have in the past years. And of course, the advances in the different algorithms that we have at our disposal right now. So I think that one of the main, and Miguel already talked about it, cities are a very, very sexy stuff right now. We are advancing very hardly on cities. And for example, we have now a project that is going to take place now, which is called Next City, it's a European project. And we are going to tackle the digital twin. And here is one of the areas that in the future, it will combine AI and geospatial very closely. So the idea that we can have not just a dashboard, but the actual virtual city, and on top of that, not just for visualization, because a digital twin it's not a pretty map, a pretty 3D map, but we can conduct and we can do prescriptive and not only descriptive, but also prescriptive analytics on top of a digital twin. So I think it will be one of the futures use of this joined together by what is the geography and AI. I think there is also some urgent needs that we must tackle, because if you think of it, today's machine learning methods, for example, they draw from no particular science domain. So it's used everywhere. And when we talk about geography, it's important for us to incorporate what is important for the geospatial part, which is spatial heterogeneity, the concept of scale, and those topics that are very closely related to geography. And sometimes the algorithms are not designed specific for that. For example, in one of the books that I'm reading that came out in December this year, they talk about the coastline paradox. I don't know if you know what it is, but if you try and go to your, for example, for Google, and you search for what is the length of the Portuguese coast, for example, and Google will give you an answer, no, some out miles or kilometers. And if you ask the same question in ChatGPT, he will answer you, depends on the scale you are measuring it. And that's important because if I draw a line in a larger scale, it will give me a measure. But if I zoom in, I will see all the little nicks in the coast. And if I contabilize all of that, it will give me a much larger distance. So somehow ChatGPT is already has some sort of spatial awareness, okay, that it's needed also in these machine learning or AI algorithms as we know it. So I think it's still an evolution that we need to take into consideration when we talk about this. And another thing that Bruno also mentioned is the interdisciplinary teams that we need when we work with GeoAI, and that's one of the reasons why. So if we are working on a specific problem, it's important to have, so I had a lot of projects, I don't know if you know, but my background is agricultural engineer, so a lot of the projects that I made in geospatial and now with machine learning and AI are very closely related to agriculture. And here the agronomic knowledge is very important. In that project that I showed, one of the things that marked, for example, the difference when we want to see the yield was the phenological data. So the actual vegetation growth of the vineyard, it's important to know where to run the LSTM model. So it was a milestone inside of the framework that we developed, and that derives from the agricultural knowledge. So that's also an important. And to finish, I think also we need to make an effort on what is the understanding and the replicability of the actual techniques, because one of the most criticized is that most of the algorithms that we use are black boxed, okay? And explainable AI should be also a very strong topic in the years to come, because science has been always concerned with the explanation and, of course, the understanding of what we are actually trying to figure it out. And this somewhat of a trending on prediction and on description. In the past, they are more or less being useful byproducts per se, but in this case, I think we need to make an effort to overcome this commercial and the sexiness of AI and try to figure it out. How can we explain more the results of when we use these type of tools?
Can I make a very quick
Yes,
interjection?
of course.
Just wanted to give you guys all you guys a pointer, because Professor André mentioned digital twins, something we're also looking at. And Utrecht, the Dutch city Utrecht, I'm probably not saying it right, built a digital twin on Unity, the video game engine Unity. So if you guys play video games, a lot of them are based on Unity, and they built it on Unity at a very, very low price compared to, I think, some Spanish cities that hired companies to do it, and they paid a lot more. So look it up. I think it's open. You can look at the digital twin right now if you want to look it up. Just wanted to give that pointer because I looked at it. It's pretty cool. It's very cool.
Nice. Well, open floor. I don't know if anyone also wants to bring in some new information. Also from the audience, if there's also any questions that you'd like to ask about this specific topic. Gonçalo? Yeah?
Thanks for the inputs. My question regards more to scalability. Knowing that a lot of the investments and the developments are based on the municipality's investments itself and like the collection of new data points, how do you see that like these systems scale so that it can be widely used like in data science, but at the same time or at an easy access to everyone to use that type of data? Because right now it seems that it is highly selected, like on metropolis, and not as much eventually like on smaller cities. So it seems like it's a system that like there's a lot of data whenever we invest on it, but if we don't, like it seems like there isn't that much open data. So my question goes more to like how do you see the system evolve so that it becomes more democratized and more widely accessible?
Well, we have a large project here in the lab that it's called Smart Region. If you look it up in our website, and the idea behind the project was also regarding the open data. So it's important, and when you say there is always a lot of data, and we are always talking about, oh, we have a lot of data, we don't know what to do with data, and machine learning is going to help us to deal with big data, but actually the first problem that we have in every project is accessing the data. It's not easy, and sometimes for that specific project, we come together with two approaches, the top-down and the bottom-up approach. So we call the bottom-up the municipality data that comes from sensors or transactional systems that they already have. And then the top-down data is from outside of the municipalities. And we have a lot of data. For example, we talked about Waze, OpenStreetMap. We have data regarding the monetary transactions, but that is paid data. We have from enterprises. We have a lot of data. Sometimes we have to pay, but I think regarding municipalities, it's an art subject because it's difficult to have a network of sensors. It's costly. We have an example here in Lisbon that we have all the sensors from the LoRa network that was disconnected in January, for example. So we stopped having data from, I don't know, 16 or more sensor locations. Way more. Okay. So I think.
What kind of sensors? Sorry for interrupting.
It's sensors regarding air quality and climatic sensors. And also noise. So I don't know. It's always a struggle. Data is the first thing.
I think continuing what you were saying, one of the things that it's going to be mandatory. It's two ways. One, it's in the budget of municipalities. It's the buying of data, like buying Waze data, SIBS Analytics, which is the company that manages ATM. Things that are important to measure different scopes, and this is exactly what we did. And on the other hand, there should also be some, I don't know if it's regulation or what could be done there, but for example, in terms of communication data, for example, data where people are, the municipalities should be able to get that data without paying it. It should be something that the municipalities or I don't know what administrative level should be, but should be able to be owners of that data as well, because the data is produced there. Yeah, and so it's maybe an unexpected turn. But there's, for example, OpenStreetMap. It's something that more or less solves it because there's the community that provides some data. Generally, that data is static. You have data about services. If you want dynamic data for some municipalities that are not rich, let's say, or that are not the ones near the capital and so on, they are not going to have it because, they don't have the investment, or those are not priorities, and fair enough. And so what ends up happening is that the private sector is able to fill that gap. And by private sector, I mean the applications like Waze and a few others. And the municipalities should be able to take advantage of that, either by buying or by having some protocols that allow them to access that data easily.
I'll quickly interject to say that if it makes you feel better, we at Port Digital also struggle to have access to data, even though we have a special relationship with the Porto municipality. For sure, standardization between municipalities is, we didn't mention it earlier, but I think it's going to be a trend, and I hope so. There is work being done, at least in Porto, to making more data open. But I think as someone who has done projects as an outsider, like the last one I showed, for sure it's an issue to do a project on a bigger scale than the municipality, because I did the math one day, and if I wanted to do a project like the 3D rail project that I showed, but looking at more amenities like hospitals and health centers and access to schools and all that, because I've also done something like that before. I didn't show it. And by my account, I would have to consult 100-something data sources, each with their own format, some CSV, some, so that just makes it impractical for someone outside. And even for someone inside, it makes it very costly. So you will have, are less likely to invest the effort in doing that. I wanted to say more, but I see we have people with hands raised, so let's cut it here.
Yeah. So, some more questions?
Mic check?
Yeah.
It was mentioned the unavailability of the data. I'm wondering how plausible would it be to create these sensors, such as air quality sensors, using cheap boards such as Arduinos or Raspberry Pis, and deploy perhaps hundreds of these?
That's possible. It already exists, but here we have a problem, which is the data quality. And if we started to take decisions based on data, you need to have sure that the data has quality. And if we are talking about environmental sensors, air quality and stuff like that, that can impact hugely, for example, on a public health decision to be made, I need to make sure that the device that is measuring is making correct measurements, and that's huge. And most of those sensors are cheap for a reason, because they are not very good. So that's a question.
I wanted to give an example. I watched the presentation by Lisboa and Nova, where they presented their work on monitoring air quality in Lisbon. They have something like 80-something sensors throughout the municipality. Don't quote me on this because it's not work that I've done, but I think it's something like 80 sensors. And they mentioned that some of the early data they had to be, I think they had to discard it. I don't think they were able to correct it because the sensors would saturate. With so much pollution, it's kind of sad, so much pollution would actually saturate the sensors and they would stop sending reliable data. And these are not cheap sensors, as Professor André was saying, and they still have these issues. So while I do believe in the crowdsourcing of sensors, I know some people who are doing it, like installing pollution sensors on bicycle handlebars, for example, and cycling around the city to measure. There's projects on this. I do think that those might be, let's say, early stage projects to start measuring something and get a jump start on things. If we want to take more reliable decisions, I think at least the richer municipalities can and should invest in higher quality sensors owned by the city, also to ensure that, if the project maintainer decides to have kids, the project doesn't stop, because those things happen in open source projects and crowdsourced projects. They always have one, unless they're very big, they tend to have one or a few core maintainers. And these big decisions should not depend on that. So I think both things can exist, but I do agree with some of what Professor André said.
But of course, you can have different approaches. So you can have, probably you don't need to have that much of a network of sensors to sensorize everything, but probably you can have a couple of them in key places, okay? And then the other thing, you can sensorize without having sensors. And this is done, for example, regarding weather variables. And with satellite imagery, it's very much possible to do that. And we use the actual sensors with high quality to calibrate the model. So it's something that we can do, and we already do it in a number of different variables. So it could be a way to solve that.
There was at least one more question, I think.
Yeah, I think we can take that one. It's an interesting topic.
Miguel, you mentioned the project is open source, and I guess then you have an interest in like making what you do open. I was wondering about any projects that you might have worked for and where more than the code is actually open. Like rather than hunting for data, you would federate it, maybe with like semantic webs technologies. And then the actual product that you're making is not the code itself, but would be the ontology, like how do we format data, how do we have multiple cities and global-wise institutions working together and being able to exchange this data so that what you do is actually replicable according to these formats.
Okay, thank you for the question. So I think picking up on something that Professor Bruno said earlier, OpenStreetMap is, I think, I would say almost a de facto open standard for, or at least open repository for data, although it's for static data. So for example, information on streets, configuration of streets, number of lanes, whether it has a sidewalk or not, that information makes sense and it exists on OpenStreetMap. But dynamic data such as traffic counts, like how many vehicles pass through here at a certain in a certain time interval, that layer doesn't exist in OpenStreetMap. So there is something that we work with, which is an open standard for city data. This is called Smart Data Models by a company called Fiware, F-I-W-A-R-E. So that's a standardized data model for anything you can think of in a city, such as air quality measurements, traffic data, what have you. A lot of standardized data. So hopefully, this data model came out, I think, of an European project whose purpose was to design a standardized data model. So hopefully, as more and more cities, at least they use this model, once data becomes open, which is a separate issue, at least it will follow the same standards, or at least closer standards. So that hopefully solves part of the issue. About data being open, so you mentioned code being open. I think to make these things reproducible, both code and data need to be open. About open data, I can understand from the outside, because I've also done projects as an outsider, that it can sometimes be frustrating that you don't have access to data where there's no personal information, such as vehicle counts or bus positions. Why isn't that data open? Now that I'm on the inside and I interact with the people taking care of this, it's a massive undertaking. If you think of all the data that exists in a city, a lot of cases this data is not really clean. Sometimes the people who are experts in this data, they have left the municipality already. So there's a lot of, let's say, people problems or human problems interacting with this. But there's actually a team of the Porto municipality whose sole task is to make more and more data open. Porto has a public open data portal. But for sure, I would agree with you that there's a lot of data that is not there. And I think that's work that needs to continue. About the code of the projects that I've done personally, I've always made the mistake of thinking, I will make this open source once the code is good enough, and then I never did it. I'm probably not the first person to end up here. In the case of these 3D maps and also the other project I did, which was roughly to try to map the Lisbon metro area as a 15-minute city, computing walking distances to multiple amenities, as Bruno was also mentioning, so probably some similarities between these two things. I actually got hired by Port Digital in the meantime, and then I was actually spending time at my work, and I didn't have a lot of free time to do that. The work done by Porto Digital, and including my own, there's also a mandate by the vice president of the city hall, which is not a mandate, but at least the indications we have are, let's make the code open. So there's what I mean by this is there's no instruction not to make it open. Quite the contrary, the instructions we have are make it open if you can. We also have a lot of other things to do, and that tends to get in the way, as with, I guess, many lines of work at companies and institutions. And I wouldn't even consider myself an expert on how to get a project open sourced. So maybe other people here can contribute better than I can.
No, just to wrap up this, we are now starting what is a national intelligent territory initiative or strategy that started in December. And one of the projects, we are involved, of course, in this project here at Nova Cidade. And one of the things that we are going to do is try to utilize the standards that already exist and create not a data catalog, but a data model catalog. And this is for, of course, providing what will be the minimum model for that specific data set. And we are going to compile more than 80 different types of data sets, depending on what they can be used for a smart city and a smart territory approach, and these data-driven public policies. So it will be, of course, there will be, of course, a repository of data, and that repository will be mainly for the municipalities, but of course for the academia and the enterprises and everyone that lives pretty much in every municipality and every territory. So it's an initiative that hopefully will try to standardize a little bit more and to be more usable, I think.
I think it's really interesting how the conversation went to more the data-centric approach of how to work with data science, which is actually what, well, many of us have to go through, right? Yes, so now we should go for the final topic. Let's discuss technologies. So my final question is, what technologies do you think are essential to working with geospatial data? And what advice would you give someone new to the field? We could start now with Miguel.
Where's the pointer?
Oh.
Okay, thank you. So essential, maybe none, in the sense that you can live in the Python world or in the R world, or even in the ArcGIS world. So
Got it.
that means that there are alternatives, which means none of them is actually essential. I've taught, during the pandemic, I taught pro bono some people some basics of data science. And I had to decide, well, I don't know R, so that already biased me towards teaching Python, which is my comfort zone. But to justify that choice, I went and looked at Stack Overflow to see how many questions do you have in the R side or in the Python side, and it was 9-1 in favor of Python. So one advice would be, if you're not yet invested in either of these, I would say Python has more people working on it. It's not just a popularity thing. It means, for example, if you're running your code and you have an error, which everybody has gone through this, and we will go through this many, many times until ChatGPT replaces us, Googling the error and finding a good answer to your problem is more likely in the Python world. I think that's maybe the biggest advantage is precisely that you have 9 times more questions and answers in places like Stack Overflow. I didn't check blog posts on Medium or whatever, or towards data science, but I don't know what the ratio would be. I would imagine that it's still in favor of Python, so that would be my first suggestion. If you're not invested in one of them, I would say Python. If you do decide to invest in Python, I would say, well, some of them you will probably already kind of know that I would answer this, Jupyter Notebooks, Pandas and GeoPandas, specifically more on the GIS side. and I wanted to grab the pointer because of that. This map, or the first few maps I showed, are done in Folium. This is a Python binding for Leaflet, which is a very well-known library for JavaScript for building maps. So Folium would be a good approach. I think it's the most used mapping library. It's not my favorite, but because it's the most used, it's something that you should have a look at. It allows you to do even animations, for example. You can do it in Folium. So if you want to show maps where frames are changing over time, you can do that. This map was done with Kepler. I would probably not advise you to use Kepler if you're starting out, because it's more of I would say, a bit of a beta stage tool. It's backed by Uber, so there's people from Uber building this tool. They were unhappy with Folium, or Leaflet actually, and deck.gl or PyDeck. So they set out to build a tool that suited their needs better in terms of visualizing, I would imagine, data from trips and from where people are requesting more rides, and the problems I imagine the Uber data scientists have. There's PyDeck, which is a Python binding for deck.gl. Kepler also uses deck.gl, so you get maps a bit like this. One of the things I like about PyDeck, first of all, I think the maps just look better visually. That's my personal preference. But you can do 3D maps, and I think, for example, this map, I think, would be very hard to visualize without 3D. Visualizing population density maps very easily and very intuitively to a 3D map. The dashboard side, so like I said, this thing is a dashboard, so if you hover over one of these circles or one of these markers, you can see some information on it. On this project, we don't have it yet, but on my personal projects, if you click on the map on a certain area, you can actually change other elements of the dashboard. So you can plot, for example, if let's say you have the map that Professor Bruno shared, and you click on a street because you see that it has bad walkability and you want to see why. So you can click on it and see and create other plots in the web page if you have an interactive dashboard. What I use for that is Streamlit. It is kind of beta at the moment, but you can already build some very cool things for it. I would say that at least to build a prototype, Streamlit is good enough. If you want to have an actual production system that will have a number of users and has to be responsive and cannot take, half a second to respond to a click, at some point you will bump into the limitations of Streamlit, but it does allow you to build a dashboard without knowing any JavaScript or React or front end. So that's pretty cool. And in my opinion, if you're starting out, Streamlit can allow you to go from, hey, I did a cool analysis in this Jupyter notebook and no one else will see it, to, hey, I built a web app that shows geospatial data. That's a big step. To do that, and that's also what I've done with my personal projects, some engineering tools I think are also good to know. Namely, I would say Docker. If you package your application using Docker, that makes it so much easier to deploy it. What I did with my personal projects is I packaged the application with Docker. I deployed it on something called fly.io. If you know Heroku, you probably know, the guys from DareData know, it's a competitor to Heroku, works the same way. You push your Docker container, you say, hey, I want this much RAM and this much disk space and these many CPUs to run this app. And then I don't need to remember. My app is actually still up, and I haven't touched it, I think, for something like 9 months. I checked before coming here, it's still up. So that's pretty cool. And I think even the best, I'm going to regret saying this, but I think even if you have very good DevOps, having a system that requires zero maintenance for 9 months is pretty good, right? So you would have to have a very solid DevOps team to build this space, for example, on AWS directly, unless you use the AWS services that are kind of like Heroku, like maybe Fargate or something like this. But if you wanted to instantiate machines and create a virtual network, it would be a bit more complex, quite more complex. I'll just pass the floor to the next person.
Yeah. So now, Professor Andre.
Well, if you are an old guy like me, you'll probably want to get away from coding, and so basically, my tool of election, of course, is being a GIS from the start. Will be we only have two options: or you go Esri and you tackle ArcGIS Pro, or you go open source and you have QGIS. And for both, you already have a lot of ready-to-use tools that you can, and of course, you still have the integration regarding Python and R. You have all the libraries there. You have the console, so you can still use it. But it's if you want to construct something really relatively easy. I know there are not softwares that you can start and okay, I'm going to start use ArcGIS Pro right now. So it has a learning curve, of course. But in terms of having ready-to-use tools, and if I can create a space-time cube, it's very easy. I can create a time series. So it's very easy to use and very easy to deploy. Of course, it has, of course, some limitation when you are working with large data sets, of course. But for the majority of the work that I do, they work just fine. So, but sometimes, and that's because I can go to the next desk and tell Bruno, how can I do this outside of ArcGIS? And I work with the other data scientists in my team.
But there are also Python plugins for...
Yes, for everything. Yeah.
But it's reciprocal because, for example, I'll give some examples of other tools, but ArcGIS is also I think it's way better to create visualizations than Python. Or I've tried some of the ones that Miguel was talking about, like
You can tell
PyDeck,
just by the images that I
yeah,
shared,
yeah.
right? They're
And,
not super pretty.
Yeah, and ArcGIS is for that it's amazing, and so a lot of times. So I ask you to create the final product as well, and particularly for articles or scientific articles where you need to have something that looks pretty good. But so complementing what was said, because well, you already covered most of the things. I can talk about my own experience, and we can start by like where should you store data if it's geographical, and I can give you two options. So you can use PostgreSQL, which has like extensions like PostGIS, which allows you to even visualize the data spatially inside the Postgres itself, the manager. And you can also use, for example, Google BigQuery, which is these were the two ones that the two that I used specifically with geographical data. And then after that, for the part of data transformation, data engineering with spatial data would also be Python. So I never used ArcGIS for that. I never used ArcGIS in general, I think. Although just saw you using it, and it was, but Python, yeah, and GeoPandas is like the most common probably library there. But then you have other stuff like Shapely. It's a very useful library if you want to make geographical operations like intersections or spatial joins and stuff like this, which is really useful when you are integrating data with different granularities, because a lot of the challenges that are spatial are the fact that you have some data at the level of the latitude and longitude, so coordinates, but other data you have at the postal code level, another data you have at the municipality level, and you have to intercept all of this and find a common ground between all this data. And Shapely is a good tool for that. Then you have Folium, we also mentioned that. Fiona, it's also another one that allows you to make operations. And finally, for the visualization part, well, Esri, you can build the entire thing there, but Esri for visualization, if it's more static, if it's more dynamic, I tend to use Power BI, which was the tool that I used where I showed you. Inside Power BI, I use Mapbox. You can just use Mapbox if you want. I use Mapbox inside Power BI. I also use Esri Maps inside Power BI. My only contact with Esri was inside Power BI. There's also an integration with Esri and with Mapbox. So you can choose one of those. Tableau, I think, also have very nice integrations, better than Power BI for geographical data, because Power BI is dependent on like Mapbox and Esri. And yeah, I also tried Kepler, and it's fine, but it's not something that well, it's not something that I think could be part of a complete solution and automatized solution, let's say. Yeah,
It's
so
still very beta.
yeah,
Kepler.
yeah, and yeah, so those are my suggestions if you guys
Can I
want to try.
quickly add something? So, not myself, but some members of the team that I'm a part of, they're building things in Power BI, namely a dashboard to look at the e-scooters throughout Porto, where people tend to use them, which routes do they tend to take, and so on. One of the challenges we've had with Power BI is deploying it. So, for example, we tend to deploy our things using Docker, just as I mentioned before. And deploying a Power BI app through Docker is something we didn't find an easy way to do it. Of course, if you pay Microsoft, they'll happily give you accounts that can access the dashboards, right? So if you have money to throw at the problem, you'll solve it. But that is something we've bumped into. Power BI though, if you don't need to deploy it like that, no, but for sure the dashboards look amazing. Like it's day and night compared to Streamlit. Streamlit is more, I would say, on the side of very flexible because it's Python. You can do whatever you want, and you can, you're building something with Python, so whatever you can normally do with Python, you can do with Streamlit, including deploying something with Docker. But I would say there's a middle ground here, as Bruno was hinting at. There's a middle ground here between, is it like rough around the edges like Streamlit, but very powerful and flexible? Or is it established like ArcGIS and Power BI, but not really a developer's tool typically, or tending to be more proprietary? So there's a middle ground here that I think is still somewhat is starting to be filled, but still not filled. It will happen in the future, I'm sure.
Can I just add? Yeah, so I agree completely. Of course, Microsoft wants you to work on their stack, and so they make it hard. But the way we do it, it's so we automatize the process of the data engineer. And for example, if you have all the ETL, the data engineering process between Postgres, Python, Postgres again, and that part you can automatize pretty much, and then. Power BI is good to read directly from databases. This could be SQL or it could be Postgres or something else, and then for this you need Pro or premium account in Power BI. I think Pro is enough. You can publish it to Power BI service and make a routine for scheduling refreshes, and then you can make it public and share it. But yeah, the engineering part cannot be deployed along with Power BI unless you do the engineering inside Power BI. As well, wish you can, but the geographical part, it's pretty much impossible to do inside Power BI.
Can you publish it as an internal tool? For example, if I want to publish it only for people in the Porto City Hall.
Yeah, if you have like a workspace only with the people from the organization.
Would they have to have
the
accounts?
domain? They need to have one account that is for everyone, or they need. No, like the premium capacity can be for it. Like if you have one person, it's for everyone. But it's rather expensive, yeah. But you can check it. But for example, one of the things that we are doing now, it's now Microsoft has this new thing which is Fabric. Some of you might have heard of it, and pretty much you can create the entire BI or pipeline, whatever you call it, inside Fabric. But of course, it's something that's Microsoft. It's cloud. It's a little bit expensive, and you can use Jupyter notebooks there and automatize the entire thing. But it's not open source, and so you need some level or a company that has some size to be able to afford it and to make it worth it to apply it. So there's some challenges there.
I'll just quickly add that in Porto Digital, we generally, unless we have very good reasons to do it, we're generally not allowed to just send data to at least to non-EU cloud services. So we tend to look for cloud services that avoid the US-centric big tech giants. It's not that we use zero cloud, we do use it, but we tend to be biased towards not using them for that reason, which also makes it harder to use some of these tools.
Let's now move on for final questions. So we're finishing now with with our discussion panel. So any questions about the technology, or just any question at all right now? So.
Just a question regarding technologies, like what tools for data pipelines do you use, like Airflow or some no-code solutions?
Okay. Yeah. So Airflow, yes, we do use for data pipelines. I would say, from what I've seen, I haven't seen major differences from regular data engineering that is not specific to GIS. So we do use Airflow. We also use Apache NiFi, which is more of I wouldn't call it just drag and drop. There's some coding involved, but it's more of a low-code tool to build data pipelines. I'm not an expert. I have used Airflow in the past, but not NiFi, so I cannot give you a lot more details. We've looked at Mage, or a colleague of mine has looked at Mage. But yeah, so I would say the answer to that is, from my experience, and I'm not a data engineer, I'm a data scientist, but from what I've seen, I wouldn't say it's that different from regular data engineering. So yes, Airflow for databases, Postgres or other databases. We use something called Orion, which is a database I think more tailored to time series. But we also have a Postgres database for non-time series data. So I don't think it's that different from regular data engineering.
Okay, thank you. I just quickly to you just want to ask one more question regarding, like you mentioned that you're not allowed to load data to AWS or Google Cloud, some US-centric companies. But so what about like regions? Can you switch region to Europe, for example, and use AWS in Europe servers?
Of course, for those of you that have not used cloud, the question is very relevant because you can select the region of the world where your data lives and where your computations are done. So you could feasibly just design your whole pipeline on AWS, which is the one I'm more knowledgeable about, but I guess Google Cloud, Azure would be the same. You can say, hey, I want this to be in the Paris data center or in the Dublin data center, and then you're inside the European Union. So the answer is yes, you can do it. I'll just be honest and say I don't know exactly why this decision was made. I haven't been at Port Digital for that long, to be honest, just from spring last year. So I'm sorry I cannot give you a better reply, but I prefer to say this instead of making something up.
Mm-hmm. I guess that might also depend on the company politics, in this case, the institution, of how they want to handle the specific cases.
The public policy, public entities tend to be very scared of having things in the cloud.
Mm-hmm. And justifiably, just look at what happened, was it 2 years ago, when some data about activists was leaked to the Russian embassy or so, right? This was all over the news, and you will still hear about Russiagate. And this most likely was, I don't know, I'm not privy to the details of the case, of course, but I can perfectly imagine people doing a good faith mistake and there being no malice involved in this data leaking to the Russian embassy. And this had a massive political cost to the previous mayor of Lisbon. I'm sure this was all over social media, and I'm sure he lost some votes over this. So I think the conservatism is understandable. Because even though you might say, okay, if it doesn't have personal data, then you can send it to the cloud. Humans make mistakes, and then something might happen that some personal information is actually either leaked with it, or it can be inferred from the data that you sent to the cloud. So I can understand the conservatism.
I actually, that's a point, but I tend to disagree. First of all, because I think the cloud is not less hackable than any server that they have there. Probably it's more, the servers are more hackable because there's no security there, probably. And second, because they already use OneDrive, Google Drive as well, Outlook, Teams, and those tools are typically used. So I think they're already using the cloud just for some things. And well, it's a discussion that we could have here in the entire day. And yeah.
Yeah. Yeah. Let's go for that one first. Yeah. Let's go ahead.
So we were talking about this before. There's, at least for regarding LLMs, there's a lot of companies now that are trying to apply those solutions, and it's trending a lot. So I think that data scientists that have those capacities to work with large language models and understand the underlying things that are going on will have a lot of space to work, because there's a lot of people looking for that.
Yeah. I think Portugal is, the trending is similar to everywhere else in the world, so we are not different from that. And if you look at the 10 top jobs in the Forbes and the 10 most growing jobs, you'll see you have data science right on the top. So I think
Data engineers,
data
DevOps,
engineers,
yeah, all that.
it's the same trend, I think.
So to give you a concrete example from Port Digital, a colleague of mine is using ChatGPT to correct or to make suggestions to correct entries from a database of tourist locations, so museums, theaters, tourist spots like, you know, viewpoints and all that. To give you an example of something he's done, all of these entries have text in Portuguese, Spanish, and English. This was all entered by hand by someone from the city hall, so naturally it has inconsistencies and mistakes, and he managed to get ChatGPT to make decent suggestions for correction. This has nothing to do with geographical data, but it's an example of an application. Another application that we're exploring is improving on this traffic data counting by using video cameras. This improves in at least two ways. First of all, these sensors, they use, so this is essentially an electric current going through this induction loop, and if you have a large metallic object going through, I'm a physicist, sorry about this, I'm gonna nerd out a bit here. Maxwell laws say that if you have an electric current going through a loop, it will create a magnetic field. If a metallic object goes through, it affects the magnetic field and will affect the electric current in the loop. You can measure that. This is a fairly indirect way to measure traffic, and by comparing the counts from these sensors to either people counting on the street itself with something that you click to count cars, or the people from the city hall monitoring the video cameras and counting how many cars go through, for example, in a 10-minute period, we know that this data has some error. I would say maybe 5 to 10% errors in the counts. It's not horrible. You can still make some inferences, but if you want to make better predictions, then you start bumping into this error. And we are now moving to a stage where we want to install some video cameras that have built-in video analytics in the cameras themselves, so the data does not go anywhere. And they will do video count. They will use the video to count vehicles with better precision. That's one improvement. Second improvement is they tell you the type of vehicle. For example, one of the things we are not sure about is we know, or the people from the mobility division, they suspect that VCI, which is that kind of ring road drawn in purple over there, it's kind of equivalent to Segunda Circular here in Lisbon. Similar type of profile, you know, kind of a bit already highway or at least freeway type of roads in Porto. And the mobility division has a hypothesis that maybe freight traffic, so trucks, are overloading VCI just to go through, like from east to west, without having Porto as a destination. First of all, and this is one of the issues we have, VCI is not managed by the Porto municipality, is managed by Infraestruturas de Portugal, the national infrastructure public entity. So we tend to have harder access to the data from them compared to the City Hall. But also, even if we had traffic loops, the induction loops there, we wouldn't know if it's heavy vehicles or light vehicles. So even though we're not building the video analysis model, we would be using an AI model to measure this. We've also dabbled with a tool called Good Vision to try to do this. One of the issues we have, sometimes you bump into these that you would never think of type of problems. For example, the traffic cameras that the mobility division uses, they can be moved around because they want to be able to see, hey, I got reports of a traffic accident in this location. Let me move the nearest camera to see if I can look at it. Whereas if you want to do video analysis, it's very important that the video feed is always pointing in the same direction to train the model as accurately as possible. So this is one of the I would never think of this problem until I bumped into it, to be honest. But yeah, we're also using video analysis to differentiate this type of traffic. I would imagine that at some point when we do traffic prediction, this master's student that I mentioned earlier, she's trying out Prophet, which does not use any fancy AI. It's a very simple model. But for sure, especially when we want to do things like what I mentioned, that, hey, if a road has 2 lanes, I should do a joint prediction of the traffic in the 2 lanes. Doesn't make sense to consider one time series completely independent of the other time series. And Prophet doesn't do that, but there's something called Neural Prophet, which uses, I'm not sure if it's LSTMs, but it's some kind of recurring neural network. And namely, it allows you to do joint prediction using variables with different time scales and so on, and different relationships between variables. Hopefully that those are some examples in what you were asking.
Yeah. We also are using those type of cameras, and we have a project called Smart Beach, and we use it to count people entering and exiting specific sites in the Oeste region beaches for the national Instituto de Socorros Náufragos. So for the guys, the lifeguard duties. And one of the projects that they have and they want to improve right now is to use that specific cameras to predict when a people is actually drowning or not. So not actually identifying the people, but seeing the conditions on the sea that can predict there's a danger zone, and then signals directly with an SMS to the lifeguard that those particular areas are not only identifying the people, but it identified the risk of the area at real time, basically. So very cool. Yeah.
Well, we're already over time, so I guess we're all already thinking about our network time after. So I would ask that for any extra questions, let's move them to the network session. You can approach them at any time, so during the next hour, at least I hope. So yes, here we are then concluding our discussion. So there's definitely an intersection between geospatial data and data science that has a vast potential and goes far beyond even the technologies that we've discussed here. I hope that you leave the discussion inspired and recognizing that there's endless possibilities to work with this geospatial data. So just some last thank you notes. I'd just like to thank to all the speakers for being here for this very interesting discussion. Thank you also for the audience for your participation, for being here. Thank you to Nova IMS for hosting this event, to DareData, Lisbon Data Science Academy, and Constanza for helping me with this organization. Thank you. I'd also like to ask Ivo, can you come to the stage just to give us, or if you want to speak from there, to just tell us a bit about next events?
I don't want to do this on the side.
Oh, of course.
was always my dream. I hope the Oscar's music started in some but I can just leave. All right, so thank you, Gustavo, thank you, Miguel, Andre, Bruno as well, for coming here. So it was very important for us. This was our first DareData Runbook event. It's a series of events that we will do, and it's kind of a celebration of the DareData brand, I would say. Thank you, the three of you, for participating. I think it was very special and very meaningful for us as well to do the first DareData Runbook event here at Nova MS. For me, it was very special because I kind of belong to the two houses, to the two homes. I consider those my two homes. A huge round of applause that I'm going to ask right now to Gustavo and Constanza for organizing everything, as well to Margarida from our other agency, because they earn a lot during this event. Now, I'm going to shut up because I know you are hungry. So, what I would like to say is that now you will stay for the network just a bit. So, catch our speakers outside so that you can speak a bit about these topics. Feel free to follow DareData on LinkedIn, on social media, because you'll find other information about the future runbooks, because this was the first one, more are coming. And also speak with these guys on the first line right here, because they are the DareData team members and they know a lot about stuff, and they are working on very interesting projects. Aren't you? Let me see. I guess they are. But they are working on a lot of interesting projects as well. Now, Constanza is giving me some signs. I don't understand those sign language.
Last slide.
That's why I gave you the...
Oh, last slide. Okay, you want to have the QR code. Got it.
This one.
This one, yes.
Yeah.
You can follow LinkedIn right here. So you actually set up like this 5 minutes before the event, so this has to show up in some way. So thank you all. We have here present DareData members, past and DareData members. That will be future as well. You'll return, Gonzalo, don't worry. And also future DareData members. I won't spoil them, but they are there in the audience as well. So feel free to enjoy the cocktail session, networking session, and thank you all for coming for the first
Yes, thank you.
chapter of the Runbook. Thank you.